All right, so a quick recap right here is what we call a balanced chemical equation. And what we practiced last week was how to balance it. So you might be given a problem like this, and you have to figure out what coefficients go in front of all of our compounds. So I'm hoping we're pretty good at that. What we're going to be doing now is figuring out how much of a product we have if we're using a certain amount of reactant, and we'll be kind of going through the steps of how to figure this out. And the good news is it's pretty intuitive. So we can use these numbers as coefficients. You could think of these as number of particles, or it's even more helpful to think of them as numbers of moles. So if I had 2 moles of hydrogen and 1 mole of oxygen, they would react together to form 2 moles of water. So what some questions of this might look like, we'll go through a couple questions here. So if we had 2 moles of H2O, or sorry, 2 moles of hydrogen, H2, and they reacted, how many moles of H2O would be produced? So in this case, if we have 2 moles of H2 and they reacted, we would get 2 moles of H2O. So our answer for that one would be 2 moles H2O. Let's write that down. So question number 2 is a little bit harder. It says if 2 moles of oxygen reacted, how many moles of H2O would be produced? So when I look at my equation up here, this is an equation for just 1 mole of oxygen. So just like in cooking, if we were using twice the amount of ingredients, we would get twice the amount of whatever we're cooking. So if we are using 2 moles of oxygen in the reaction, we would need 4 moles of H2, and we would be getting 4 moles of H2O. So if I was using 2 moles of oxygen instead of 1, I would produce 4 moles of H2O. All right, let's go through a couple more examples. Here is another balanced equation. I would be expecting that you can balance something like this on your own. In this equation, we have urea, which is in urine. When it reacts with water, which it does over a long period of time, it becomes ammonia and carbon dioxide. And what we could see here is for every mole of urea that is reacted, we would get 2 moles of ammonia. All right, so the questions here get a little bit more complicated. If 2.5 moles of urea reacted, how many moles of CO2 would be made? So in this case, in our recipe, or you could think of it as, I should say, in our balanced equation, or you could think of it as our recipe, it gives us what's made with 1 mole of urea. But our question's asking for 2.5 moles. So all we have to do is make a 2.5 serving of this equation. So everything will be multiplied by 2.5. So if I reacted 2.5 moles of urea, I would have to multiply this number by 2.5, and that would be 2.5 moles of carbon dioxide. All right, so next question. If I was reacting again 2.5 moles of urea, how many moles of ammonia would be made? So in this case, I'm doing the exact same thing. I'm making a 2.5 batch. So I'll even write on this. Let's write on this. I want to make a 2.5 batch. So I have to multiply, this by 2.5. I have to multiply water by 2.5. I have to multiply ammonia by 2.5 and my carbon dioxide by 2.5. So whatever one I'm looking at, last time I was looking at carbon dioxide. So 1 times 2.5 would be 2.5. And that's why I had 2.5 moles of carbon dioxide. In this case, I'm looking for ammonia. So I would have to multiply the 2 moles by 2.5. And in this case, if I reacted 2.5 moles of urea, my answer for ammonia would be, I would be getting 5 moles of ammonia. All right, so I want to pause there. If this is difficult for you, which I can understand because it could be a little bit difficult, I have kind of a cutout tool that I always use to help my students. So to make this, you need just a regular piece of paper. I folded it long ways, hot dog style. And I'll need some scissors as well. Here's my scissors. And I'm going to cut 3 slits in here, only on the top flap, so that I have 4 flaps that I can fold up. So I got one right there. One right there, and one more cut will make the last 2. There we go. And on the front side, I am going to write mass A, moles A. And on this side, we're going to write moles B, mass B. And if we flip the middle 2 up, I got something we're going to be writing in here. I'm going to be making some parentheses. And I'm going to put moles A on the bottom and moles B on the top. And when I'm doing this, I'll just write coefficients over here. And the coefficients will be going in here. All right, so now I'll put these down. For mass A, what I'm going to be putting right here is divided by molar mass A. And the last thing we're going to do is we are going to flip over mass B, and we are going to write times molar mass B. And what this is going to help us do, I want to make sure I explain this well, what this is going to help us do is it's going to help us figure out how much we started with of something. So how much we have, either mass of A or moles A. And in the end, it'll tell us how much we have of that thing. In these questions, we're just going to be starting with moles of something and getting to moles of something. What we're going to be doing later in the week is we're going to start with mass of something and end with mass of something. So that's the goal. When we measure something, we're always going to be measuring in terms of mass in this class. So we measure the mass of something, we can calculate the moles, and then in the reaction we can see how many moles of something else we'll get, and we can always calculate that back into mass. So that's what this is made to help us do. So we could even go back and take a look at some of these questions we've solved already. And we could see if this works out using our new tool here. So it was if you have 2.5 moles of urea, that would be A, that's what we're starting with. And they reacted, how many moles of CO2 would be made? So the way I would figure this out, I'm starting with moles of A and I'm trying to get to moles of B, which is carbon dioxide. I would just put my coefficients and I would have to figure it out like that. So it would be, I would start off with 2.5. I would multiply by whatever I have here. So I'd multiply by 1. And I would divide by whatever coefficient I have for A. So I would divide by 1. So it would stay 2.5. If I was in the scenario like in question number 4, let's take a look at this one. If I had 2.5 moles urea and they reacted, how many moles of ammonia were made? Again, I take a look at my coefficients. And for ammonia, my coefficient was 2. And for urea, my coefficient was 1. So it'd be 2 divided by 1. I would have to multiply by 2. Well, 2 divided by 1 comes out to 2. So I would have to multiply however much I started with, 2.5, by 2. So the reason this gets really helpful is because equations do get a little more complicated. So here is another balanced equation. It is octane combusting with oxygen, so they're reacting, and they're forming carbon dioxide and water. You could think again of this again as our recipe. If we mix 2 octane and 25 oxygen, we mix them together, what we'll end up with in the end is 16 carbon dioxide and 18 water. That's our recipe. So a question might look like this. If 4 moles of octane react, how many moles of O2 will be needed in the reaction? So I'm going to be going from octane to oxygen. So all I got to do is take a look at their coefficients and just plug them in here. So moles B in this case will be my oxygen. I got to fold these all the way back so I got room here. So it would be 25 up here. And moles A would be this coefficient here, 2. And then I always start off with what they give me, so 4 moles. So my answer would be, I will just write out the math right here. The answer would be 4 moles times my coefficient from mole B, 25, divided by my coefficient from where I start with, and it would equal, in this case, that would equal 50 moles O2. So if 4 moles of octane reacted, I would need 50 moles of oxygen in order to complete that reaction. All right, let's take a look, one more example today. And sometimes reactions happen with just decimals, like fractions of a mole. All right, so this question is, how many moles of carbon dioxide? So now I'm taking a look at this section right here. How many moles of carbon dioxide are produced if 0.75 moles of octane, so this will be my moles A, this will be my moles B, are reacted? So let's do that again. We're starting with the number. So the number I give you is always the number we start with. So we start with 0.75 moles of octane. And I'm going to write out octane here, just because it's good to always keep track of what you're doing. 0.75 moles of octane. Now, what we got to do to find our answer is we got to get the conversion of this right here. So moles B is what we're turning it into. That would be carbon dioxide. So it would be 16. And I'll just put CO2. And moles A, what we're converting from, that would be octane, would just be 2. C8H18. So our answer would equal 8 times 0.75, so it would be 0.75 times 16 divided by 2. If you plug that in a calculator, your answer will equal 6 moles of carbon dioxide. All right, so we will be doing a lot more problems like this later in the week, and then the problems that we're going to come to next are, what if we start with mass? If we start with mass, we have to convert it to moles first. So that's where we're going to be going later on in the week.